Hello, this is a video for the review for the first semester final. So we're going to start with Module 1. Let's begin. Number 1, it says factor completely, so we are going to try using, the x first. Okay. First, I want to check if there's any kryptonite. So is there a common factor in each of the terms, which I don't see any, and then is the beginning term negative? Nope. Okay, so then we're going to multiply a times c, which is 35 times 6, which 18, 19, 20, 21. All right, so 210. Factors of 210, that would give us negative 31. So what I like to do whenever I've got big numbers like this and I'm trying to figure out what the factors are, first I look at the top and I see, okay, since this is positive, that means that either these are both positive or they're both negative. So basically the signs are going to be the same. And then down on the bottom, since the b term is negative, that means that both of them are going to be negative. So what I do is I take the factors that got me this, which are 35 and 6. And I know 35 times 6 would give me 210. And so now what I need to look at is say, okay, do any of these add up to this number? Okay, so right now 35 plus 6 will not give me 31. So let's try to change this up a little bit. How about 5 times 7 times 6? I know that'll equal 210. So if I rearrange this and say, how about this right here? This is 42. 42 times 5, that won't give me 31. Okay, so maybe if I do 5 times 6 would be 30, plus 7, that won't give me 31. So it looks like I'm going to have to break up this 6. So if I break up the 6 to be 2 times 3, let's see if we can rearrange this. We got 14 and, okay, so this would be 14 and this would be 15. So it's 15 times 14. That won't quite give me 31. So how about this would be 21 and then this would be 10. So 10 plus 21 would give me 31, so those are my factors. So 10 and 21. We have to divide by our a term, which is 6, and then reduce the fractions if possible. So over on this side, I see that there's a common factor on the top and the bottom of 3. So I divide this by 3, which would give me a 7. Divide this by 3, which would give me a 2. And then over here, there's a common factor of 2. So divide by 2, that'll give me a 5 on the top. Divide by 2, that'll give me a 3 right here. Okay, so these are the factors. And just remember, we're going bottom, left, top, right. So if I'm doing this first factor and I'm writing it in parentheses, the bottom is going to go on the left, 3x, and then the top is going to go on the right as negative 5. That's this factor. Now, I'm not going to stack them. I'm going to put them side by side. This one over here is going to be 2x minus 7. Okay, factor completely. We just did that. Okay. Okay, next one. It says, is the equation, this guy, equal to this for all values of x? So what it's looking for is if when we solve an equation, basically, we can get one solution, just like if I had something like this, where it was 2x equals 4. I mean, we're going to get one solution here. There's no other possibility, like 2. X has to be 2. There's no other way that I can get other values of x and make this sentence true. Okay, so here what we're looking for is a situation where we're going to end up with, no matter what we substitute in, it's always going to work. For example, if the equation was this, y equals x. Okay, whatever value of x we put in, it's going to be balanced. It's going to, well, hold on a second. That's not going to work. JK. X equals x. There it is. Okay, so whatever value of x I put in here, if I put in a 2, 2 equals 2. So that works. So that's what we're looking for here. So I'm just going to simplify this a little bit. Yeah, so I would go square this, so it's going to be x squared. I'm not distributing. X squared, and then I'm going to have 8x, and then at the back I'm going to have 16. Okay, and then this is being multiplied by 16. And then over here we're going to have, I'm squaring the first term, which will be 16x squared. And then the last term will be 16 squared, which is 256. And then in the middle is 4 times 16, which would be 64. 64 double that, which will be 128. So plus 128x. All right, so now looking at this, if I was to go 16 times x squared, that would be the same. So right now the first terms are looking pretty good, okay? Because if one side equals the other side, then that means that it's going to be true for all values, okay? And then 16 times 16, that gives me 256. So right now the beginning terms and then the last terms are right now looking identical. So next what I want to see is if I did 16 times 8, would that give me 128? And I'm not really sure offhand. So 8 times 6, 8, and then that's a 4, and that'll give me a 20. Yeah, okay, so it checks. So then, is the equation this equal true for all values of x? The answer for that would be yes. Okay, next, Emma wants to plant roses and tulips in her yard. She would like to plant at least 50 of those flowers, but she wants to plant less than 20 tulips. Write a system of inequalities that represents the situation. Let R equal the number of roses and T represent the number of tulips. Okay, so here she says that she would like to plant at least. Okay, so what we need to identify here is what does this word at least mean? What does at least mean? So let's say that your parents said, all right, you're going out Christmas shopping, and you better spend at least $20 on myself, you know, or at least $20 on your dad or something like that. So if you have to spend at least $20, let's say that this is you spending, does that mean that you can spend $20 if they say at least $20? Yeah, okay, so you could spend $20. Now can you spend $19? Could this side be a 19? Well, would that be at least 20? No. So basically whatever you have to spend, it could equal 20, but it also has to be greater than 20. So this word right here, or this phrase, is this symbol right here. So she would like to plant at least 50 flowers. Of those flowers. And she wants to plant 20 less than. So what is less than? I think we know that one. Less than is that guy. Okay? 20 tulips. So now we have to write a system of inequalities based upon this information. So she would like to plant at least 50 of those flowers. So R plus T. Okay, so roses and tulips, she wants to plant at least 50 of those. Okay, so this would be our first inequality. And then the next thing she says that she wants to plant less than 20 tulips. So when it comes to the tulips, she wants to plant less than 20. Okay, it says write the system of inequalities that represents the situation. Doesn't want us to solve, but this would be the situation. So we have two scenarios where she wants to plant at least 50 tulips. That's a top equation, our inequality. And then on the bottom it says, but she also wants to plant less than 20 tulips. So the tulips has to be less than 20. So you would then just solve that, but it's not asking us to solve it. We just need to write the equation. Bam. Alrighty. Next one. It says the formula for a trapezoid where A is isolated is shown. So I think what this is wanting us to do here, I think I read it before, is that it, based on this formula, which of the following formulas are also true? Okay, so look over here on this side. The original formula, A is by itself. Over here, we have B sub 1 is isolated. So let's see how we could isolate B sub 1. So I'm going to go ahead and rewrite the formula down below so I can start working with it. So H is right there, B sub 1, and then B sub 2. Okay, so how do I start to get this B sub 1 isolated? Right now you have to treat this like this is the X. This is the variable that we want to get by itself. So let's look at the things that are going on. We have plus B sub 2, we have multiplied by H, and also multiplied by 1/2. So let's get rid of these things first. The A is still going to be on that side, but in order to undo multiplication, why don't we divide the 1/2 and then the H. If we divide both sides by 1/2 H, or basically we're multiplying by 2, okay? Divide this side by 1/2 H, then that's what this would look like. And then we're left with the B sub 1 plus B sub 2. Okay, now I'm going to go ahead and highlight this, but also I want to get rid of this fraction in the denominator because over here I don't really see a fraction in the denominator, right, for the b sub 1 isolated. So this is the same thing as having a, and then move that 2 up, okay, and then over h. So I've got this. How do I get the b sub 1 by itself? I have to subtract the b sub 2 from both sides. So subtracting b sub 2 from both sides gonna give me something that looks a lot like this, with the b sub 2 right here, and then I still have the b sub 1 isolated. Okay, so looking at the answers for b sub 1 being isolated, I see that it's b sub 2 is minus a, see how the 2 is on the bottom? So this one can't be a possibility. Okay, now over here I see a is negative. A is not negative and 2 is not on the bottom, so this one can't be a possibility. So great, we just did that for nothing. Not really, we just were able to eliminate those. Okay, so let's go back. Let's get the formula. And let's try to figure out what the next thing it's asking. So here I see b sub 2 is isolated. So I'm going to end up with the same general idea. I'm going to have 2a on this side, and then when I divide, I'm going to have h on the bottom, and then I have b sub 1 plus b sub 2. So how do I get the b sub 2 isolated? Well, if I subtract the b sub 1, I'm going to look at something like this. Okay, so let's see if this is what we have. We have 2a over h minus b sub 1. So this one definitely looks like what we got. So C would be one of the formulas that are also true. And we can't stop there because this one has h isolated, so we have to consider that. So let me get this back to the original formula. And now we want to get h by itself. So to get rid of the 1/2, we're going to multiply by 2. So I have 2 times a equals h times b sub 1 plus b sub 2. And in order to get all of this away from the h, let's consider what the operation is between them. So I have h right here. So if I'm this is basically being multiplied. So the undo multiplication is we're going to divide by all of this stuff, b sub 1 plus b sub 2. So divide that, b sub 1 plus b sub 2. And so that's what we're looking at when h is isolated. So let's see if we have any takers here. 2a on top, b sub 1, b sub 2 on the bottom. I don't know. Well, that's actually not bad either. Okay, so look, D is an answer. But remember how if we were to divide by 1/2, the 2 would be on the bottom, or basically the 2 would be on the bottom as a 1/2. Okay, so let's just say that we had a 1/2 still down here and we didn't move it up to the top. Would we have the same answer? This would be distributed, so that would be b sub 1 times 1/2, and 1/2 times b sub 2 would also give us this. So this is technically also a solution. Crazy, but that's it right there. All right, so for number 5, it says find 3 points that are on the following graph. So right here we see that this is an absolute value equation. I don't know how I can tell that it's an absolute value equation. I just think I've just been doing this for so long I can tell. Anywho, simply what this question wants you to do is just create like a t-chart. Find 3 values, like ordered pairs that would work. So if we were to put in, let's choose something real simple like 0. If I did 0, substitute 0 in there, then I'd have 0 minus 2, which would be negative 2. The absolute value of negative 2 would be 2, and then 2 minus 1 would be 1. So at 0, it's going to be 1. So one of my ordered pairs that I could say is on the following graph is 0, 1. Okay. The next I can try is doing something real simple, like let's say that I just want this to cancel out. So if I choose 2, okay, 2 minus 2 would give me 0. Absolute value of 0 would be 0, and then 0 minus 1 would just be minus 1. So another ordered pair would be 2 comma negative 1. Okay, the next one that I think I will try is something also simple. Let's say if I did 3, because 3 minus 2, that's something easy to work with. So 3 minus 2 is 1. Absolute value of 1 is 1. 1 minus 1 would give me 0. So then the last ordered pair would be 3 comma 0. Real basic, just make sure that you understand what it's asking for here, okay? When it says points, it's talking about ordered pairs or coordinates or whatever. Okie dokie. All right, next one. 6. It says factor the quadratic function. So here I'm going to use the x. 4 times negative 5 would be negative 20, and then negative 1 would be down here. So factors of negative 20 that would give us negative 1 would be 5 and 4. And then since it's negative up top, that means that one of these has to be negative. So I look at the bottom, I see that this one is a negative, so that means that the bigger number has to be negative. Now don't forget to divide by your a term, which is 4, and then reduce. So this becomes 1 over 1. Give the variable to the bottom, and then this is going to stay the same. I can't change that or reduce that. So anyways, to factor this then, I got 4x minus 5, and then this one over here is going to be x plus 1. So these are the factors right now, and it's really important you know what the factors look like. There's a distinguishing feature that has parentheses, so remember that. Now, it also says then to determine the zeros of the function. Now, the zeros are related to the factors in that if we were to set this equal to 0, we know that we would then solve each of these factors setting it equal to 0. Now, if I set this equal to 0, this 4x minus 5, I would have to add the 5 over and then divide by the 4. I'm going to get something exactly like this, except when I add the 5 over, it should be positive. So the solutions, or the zeros, okay, the zeros are going to be the opposite of what we have here. So instead of doing all that work, man, to find the zeros, okay, I'm just going to do this. Take the opposite of what I have here. So the opposite of negative 5/4 would be positive 5/4. And then over here, the opposite of 1 over 1 would be negative 1 over 1, or just 1. So these are the zeros, and then those are the factors. Bam, I don't know, that's messy. Don't worry about that. Anyways, next one, it says if I have this factor and this factor, okay, and it says that those are factors of this, which of the following must also be true? So here, what I think you should do, since you have two variables, is this, go ahead and just write this down. Okay, and let's write down this guy. And let's consider how we would get this. We know that we would get the first term by basically multiplying this guy times this guy, right? So this times this would give us the 6. And so how can we get this 2? Where does this 2 come from? Well, the 2 comes from multiplying this guy and this guy together. So when we do our last terms in our FOIL, P times Q should equal what we have here, which is 2. So let's see what we got over here. Anything like that? Nothing there. Okay. So what about the 7? Where does the 7 come from? How do we end up getting those middle terms? So the middle terms come when we take this 2x and we multiply it times the q. So 2xq. And then the other term comes from when we multiply these guys. So this will be positive 3xp. And then that should be our b term, basically, of our quadratic here. So that should equal 7, or 7x in this case. So let's take a look at what we got. If we were to divide everything by x, then we would just have 2q plus 3p equals 7. And so let's see which one of these works. So 2q plus 3p equals 7. Bam. Okay. Oh, wait, hold on. Okay, so it's not this. I'm going to, because it says which of the following must also be true, I'm not going to just settle with the first answer that I get. I'm going to double check that everything else is good. So here this says 2p. Okay, so that one's not right. Now this one is saying 6 times p times q. Oh, I see what they did. They multiplied instead of added. Okay, so that one's not right either. Okay, nice. All right, next one, number 8. It says determine whether each expression is equivalent to this. So here I see that something is cubed and then something else is cubed. What was cubed to get 8? 2, right? So we have 2 cubed and then we have x cubed, and they're being added together. So this is called the sum of cubes. Whenever you're doing and factoring the sum of cubes, and that's what it looks like it's doing here, in the first set of parentheses, we need to analyze and see which one was being cubed. Here, this is the x, and then this one is the 2. And then you square the first term, so x squared. Square the last term, which would be 2 squared is 4. And then multiply these two guys together, which would be 2x. All right, and then we use the SOAP, the same, opposite, always positive, and that's A. Okay, So this will have the same sign as this. This will then be the opposite sign, and then the last term is always positive. So we can look over here, and then, well, it can't be this one, so this is a no. And then this is minus right here, so this one's a no, and this one's a plus, minus and then plus, so this one's a yes. All right, nice job. All right, number 9 looks pretty bad. It's not that bad. Okay, so let's get started on this. So here's the deal. It says a rectangular garden measures 13 by 17, the dimensions are given, and has a cement walkway around the perimeter. Okay, now the perimeter, well, we could figure out of the garden, but we don't necessarily know of the whole garden and walkway. So it says the width of the walkway remains a constant on all 4 sides. The garden and the walkway have a combined area of 396 square meters. So let's see what we have to do. Part A, it says write an equation that could be used to help determine the width. Okay, so we'll start there. Well, we know that when it comes to the area, okay, the area is the length times the width. Okay, so length times the width equals 396. So let's see if we can figure out what the length is, okay? Or maybe we'll start with the width, I guess. So here we have W plus 17, and then another W. So the distance from this side to this side would be 2 of the W's plus 17. Okay, that's what we know. Let's say it's the length, okay? So the length is 2W plus 17. Okay, and then the width, or whatever, this direction, is going to be a W, and then 13, and then another W, so kind of similar. It'll be 2W plus 13. So we know that this times this should equal 396. So, I mean, we could probably do this. I mean, this is okay, but they probably want you to distribute this all the way out. And since we're going to end up with a quadratic, set this bad boy equal to 0. So let's go ahead and just multiply. So 2 times 2, that'll be 4W. And then 2 times 13, that's going to be 26W. 17 times 2 is 34W. And then 17 times 13, 221. Okay, equals 396. All right, it's looking pretty beefy. Let's go ahead and set this equal to 0. So I'm going to subtract the 396 from over here. So subtracting 396 from that. And then as I'm thinking about that, oh, I forgot the square. Okay, so W times W would be a square. So we've got 4W squared. 26 plus 34, that'd be 60 plus 60W, and then negative 396, so that's going to end up being a negative. That'll be a 175 equals 0. Okay, so this is probably the answer that they're looking for here. So write an equation. I gotcha. 4W plus 6DW, 4W squared, minus 175 equals 0. Oh gosh, okay. So now it wants us to actually figure out what W is. Okay, so I was hoping they wouldn't want that. So the walkway, which is W, how do we figure out what that distance is? Okay, now keep in mind this is distance, so when we solve this quadratic, if we have any negative solutions, we know we can get rid of them because distance can never be negative. All right, and in order to do this, I'm going to factor. Okay, now can we pull out a common factor? We could divide this by 2 and this by 2 is 175. Let me look real quick on my calculator. 175 divided by 2, please, Lord. No. Okay, so it doesn't divide. So we're just going to have to use the x. Let's see. So 4 times 175, that is going to be 700, but a negative 700. And then we have 60 on the bottom. Okay, so factors of 700, that would give us 60. Since this is negative up top, that means that one of these is going to be negative. So, and this is positive. So the bigger of the two is going to be positive. So looking at this, without looking at the bottom end, the first thing that comes to my mind is 7 times 100, right? 7 times 100 will give it us 700, which is nowhere even close if I subtract that to get to 60. So why don't we go like this? What about 70 times 10? 70 times 10 would give us 700, and then if we were to subtract those two, we would get 60. So that's the money right there. So 70 and 10 is the negative because they have to subtract to get 60. Now don't forget that we have to divide by our a term, which in this case is 4, and reduce these fractions. So here this one could divide the top and the bottom by 2, so that'd be 35 over 2. And then over here dividing the top and bottom by 2, so it'd still be negative, so that'd be 5 over 2. Okay, so the factors would look like this. Okay, but since we want the solutions, we want to know what W would equal, we take the opposite. So the solutions, opposite of 35 over 2 is negative 35 over 2. And then the opposite of negative 5 over 2 is positive 5 over 2. Now remember what I said about negative solutions that we have? We can't have a negative distance, so this one I could throw out, and this one is our solution. So we know that the width of the walkway, or the walkway itself, is 5 over 2, or that's equivalent to 2.5 feet. Wait, is it feet? No, square meters. So meters. All right, bam. Next. Okay, number 10. It says Jim can paint a house in 12 hours. Alex can paint the same house in 8 hours. Write an equation that can be used to find the time that it would take for Jim and Alex to paint the house together. All right, so I think I just know how to do these ones because I've done these before. But the formula for combined work, okay, is the time together all over time alone plus the next person, whoever it is, okay, time together divided by time alone. And then if you have more, you just keep on adding them, but it's going to produce one job completed. Okay, so let's go ahead and apply this to what we see here. So time together all over time alone. So Jim can paint the house in 12 hours. So let's say Jim is this first fraction. We don't know basically how long it's going to take them together, but we know that Jim by himself can do it in 12 hours. So that's the time alone. Okay, now the next dude, Alex, he can paint the same house in 8 hours. So we still don't know the time together, but we know that Alex can do the same house in 8 hours. Okay, now if they work together, if this combined with this produces one job completed, this is basically how we're going to solve this equation. It doesn't ask us to solve the equation, it says just to write, thank God. Okay, so this would be the equation that you would write there. Okay, number 11, it says a restaurant serves a vegetarian and a chicken lunch special each day. Each vegetarian special is the same price. Each chicken special is the same price. However, the price of the vegetarian special is different from the... Okay, thanks. So it says on Thursday, the restaurant collected $467. Okay, on Friday, it's going like this. So it says write the system of equations that model this situation. So again, we just have to write the equation. So that's not bad. So let's see what's going on here. So this guy, or this restaurant, they collected, so we could say $467 by selling 21 of the veggies and then 40 of the chickens. Okay, now do you see how 40 chickens plus 21 of the veggies equaled $467? So this represents an equation for this basically this sentence. So now on Friday, let's see what's going on. They collected $484 by selling 28 vegetarians and then 36 chicken. Okay, so here is one equation, here is the other equation. So now remember, the solution to a system is the point of intersection. So what you would have to do is use one of the methods of either elimination or substitution, or you could graph this. You could use Cramer's rule. All of those are methods to solve this system. So this is just the equation. That's all it's asking me to do, so I ain't going to be extra.